Hello everyone! Welcome back to Doc Gilmac Online Tutorial. Doc Gilmac Math TV Basic Trigonometry Tutorial. Are you ready for the next tutorial? So if you're ready guys, so let's begin. The topic I will be discussing for today's tutorial is all about how to get the area of a triangle without the given height. This time, the given are two angles and a side opposite one angle, or two angles and an included side are given. In this tutorial, I will be showing you how to derive the formula in determining the area of a triangle without the given height, wherein we have these conditions, SAA and ASA are given. Let's recall, the area of a triangle is equal to 1/2 of the base times the height, or simply A is equal to 1/2 BH. Take note, if the height or altitude is unknown, then we cannot directly apply the formula for the area of a triangle A is equal to 1/2 BH. Let's recall. Consider an oblique triangle A, B, and C. If we're going to draw a perpendicular line from the vertex B to side AC, then we have the point of intersection to be point T, wherein we form a right angle and also two right triangles. The distance from point A to point C is simply your side B, and side BC is simply your side A, and side AB is simply your side C. Take note, side BD is simply the height or altitude. The area is equal to 1/2 BH. If we are to take triangle ABD, from here we can say that sine A is equal to H over C, or simply we can also say that H is equal to C times sine A by cross multiplication. Let's substitute C sine A to the given area formula for area 1/2 BH. So we have here A is equal to 1/2 BC sine A. So take note of that. If we are to consider the derived formula wherein A is equal to 1/2 BC sine A, okay, and let's recall that B over sine B is equal to C over sine C using sine law. From here, we can say that B is equal to C times sine B all over sine C by cross multiplication. Substituting B, which is equal to C sine B over sine C, in the derived formula for the area. So we have 1/2 of C sine B over sine C times C sine A. If we are to simplify further, this is simply equal to C squared sine A sine B all over 2 sine C. So from here we derive a formula given one side and two angles. Of course, if two angles are given, we can determine the third angle. So take note of that. Applying the same process, A is equal to 1/2 AC sine B. From here, we again use sine law, A over sine A, which is equal to C over sine C, wherein we can be able to determine C, which is equal to A sine C over sine A by cross multiplication. From the given formula, A is equal to 1/2 AC sine B, we substitute the given value for C. So we have here 1/2 A times A sine C over sine A times sine B. Simplifying further, A is simply equal to A square sine B sine C all over 2 sine A. Again, we derive another formula. Applying the same process, using this time A is equal to 1/2 AB sine C. Again, we use sine law, A over sine A is equal to B over sine B. From here, we can be able to derive A, which is equal to B sine A over sine B. Substituting A, which is equal to B sine A over sine B, in the given formula for area 1/2 AB sine C. So we have 1/2 B sine A over sine B times B sine C. Simplifying further, the area is simply equal to B squared sine A sine C all over 2 sine B. Again, we derive another formula. Consider illustrative example number 1, using now what we derived a while back. Okay. For instance, we have here A, B, C. So, oblique triangle ABC, wherein side C is 8, angle A is 40 degrees, angle C is 85 degrees. From here, we can be able to solve for angle B. Angle B is simply equal to 180 degrees minus the quantity 40 degrees plus 85 degrees, which is simply equal to 55 degrees. We're going to use the formula wherein A is equal to C squared sine A sine B all over 2 sine C. Now let's substitute the given values for side C, angle A, angle C, and angle B. So we have here 80 squared times sine 40 degrees times sine 55 degrees all over 2 sine 85 degrees. Solving this in a scientific calculator, the given area is just equal to 16.91 or approximately 17 square units. Consider illustrative example number 2. So let's have this given oblique triangle A, B, and C. This time, side B is given, which is 22 units. Angle A is 28 degrees. Angle C is 64 degrees. Solving for angle B, we have here 180 degrees minus the quantity 28 degrees plus 64 degrees, which is simply equal to 88 degrees. Using the formula, A is equal to B squared sine A sine C all over 2 sine B. Let's substitute the given values for side B, angle A, B, and angle C. So we have here 22 squared sine 28 degrees sine 64 degrees all over 2 sine 88 degrees. Solving this in a scientific calculator, the area is simply equal to 102.18 square units or approximately 102 square units. Consider illustrative example number 3. So this time we have here triangle ABC where A is 11 units, angle B is 28 degrees, angle C is also equal to 28 degrees. Again, let's determine the area. But before solving the area, we must simply determine first the measure of angle A. So here A is equal to 180 degrees minus the quantity 28 degrees plus 28 degrees, which is simply equal to 124 degrees. We're going to use the formula A is equal to A squared sine B sine C all over 2 sine A. Let's substitute the given values for sine A, angles B, C, and angle A. So we have here 11 squared times sine 28 degrees times sine 28 degrees all over 2 times sine 124 degrees. Solving this in a scientific calculator, we have here A is just equal to 16.08 square units or approximately 16 square units. Again, I would like to thank you for watching Doc Gilmac Math TV. Stand by for my next tutorial. Stay safe, everyone, and may God bless us all.